After this lecture, you will be able to understand the key factors of data visualization. You will be able to get the overview of various examples related to data visualization. Data visualization is very important in decision making. Data visualization is a language of decision making. Good chart effectively convey information. Great chart enable, inform and improve decision making. Data visualization help to bridge the gap between number and the words. Data visualization and the big data. Implementing effective data visualization solution for big data has to take into account apart the volume of data, other intrinsic constraints generated by the typical characteristics of the big data. So big data is a data which is generated at very high pace with very high volume, and it is very complex data. So big data, it includes the real-time changes, extreme variety of the sources, different level of the data structuring. So there are different types of the data: structured data, unstructured data and semi-structured data. So even when the data is real data, real-time screening data, that also included in the big data. So moreover, it is advisable to simultaneously use several visualization techniques to better illustrate relationship among the large amount of data. So it is very important to convert the big data into information, then information into knowledge, and then knowledge is used for the purpose of a decision making. So that is why data visualization has a great role to play in that. So when data becomes big, so when data is in motion, data at scale, data in many forms. So data in motion, analysis of streaming of data to enable decision within fraction of second. So when data size is very big, when data is of many forms: structured, unstructured, text data, multimedia data. So these are the complex information spaces and extreme scale. So three critical elements in applying visual analytics to extreme scale data and the complex information spaces, that is the size, inclusion of the visual and analytics, and active involvement of a human. So when data become big, when data is basically of high volume and generated at very high velocity and is of different types. Big data building blocks, it consists of collection of data, cleaning the data, integration of data, then analyzing the visualization, analysis of the data, presentation and dissemination of the data. So big data building blocks, big data is built, as I discussed it with you in the last slide, that what are the building blocks, what are the various parts from where we can consider a data into a big data if the data is of different types. So for data collected from different sources, then it required to clean the data, then integrate the data. Then after analysis and visualization, data is used for the presentation and for the decision making. Role of data visualization in the big data. Data visualization can play a specific role in several phases of the big data lifecycle. Data type can affect visualization changes. Visualization methods can inform data cleaning and the choice of analysis and the algorithm. So data is basically collected, then data is extracted, transformed and loaded into the system, then data is used for the purpose of analysis. We discuss about the data exploration. Data exploration means how can we prepare the data to be ready for the decision making. So along the big data lifecycle, visualization methods can be properly incorporated in three phases: pre-processing, staging and handling, exploratory data analysis, and presentation of the analytical results. Pre-processing, when data is collected from different sources, data can be in different basically data types or different formats. Now it is very important to club the data into a common integrated format which is used then later on for the purpose of the exploratory data analysis. Then the presentation of analytical results. Whatever the results that we have got in the pre-processing and exploratory data analysis, then it is very important to present the result and basically deduct some decision to check for some decision making from that analysis. How can that particular graph can be used for the purpose of decision making if it is represented properly by the graphs? When graphs are created from a data, then it is very easy to analyze the data for the purpose of the decision making. There are three styles of the big data visualization. It can be data reduction, visual interaction, and HCP. Data reduction. A big data can be reduced to medium data and to small data. So there are some research papers which are supported this fact that big data can be reduced to the medium and the small data, and then the analysis, the result can be basically reduced from that particular big data. Visual interaction. So data can be converted into graphs and parallel coordinates. To check it for the analysis, then HCP, divide and conquer, and parallel computation. So these are the different styles of the big data visualization. Automated analysis and interactive visual methods. In order to support the entire life cycle of a big data, a good visual analytics system has to combine the advantages of the automatic analysis with interactive techniques to explore data. Behind this desired technical feature, there is a deeper aim to integrate the analytical capability of a computer with the abilities of a human analysis. Volume, velocity, and variety, these are the important properties of the big data. Mapping complex data into more a simple visual form of a knowledge. Appropriately definition in the phase of a design and implementation of a specific weight and right balancing of the two components. Data visualization best practices. Set the context. It is important to provide general background information to the audience around why this particular data point is important. For example, if email open rates were underperforming, we may want to illustrate how a company's open rate compared to the overall industry, demonstrating that the company has a problem with this marketing channel. To drive an action, the audience need to understand how the current performance compared to something tangible like a goal, benchmark, and KPIs. Know your audience. Think about who your visualization is designed for and then make sure your data visualization fit their needs. What is that person trying to accomplish? What kind of question do they care about? Does your visualization addresses their concern? You will want the data that you provide to motivate people to act within their scope of their roles. Know your audience. If you are unsure if the visualization is clear, present it to one or two people within your target audience to get feedback, allowing you to make additional edit prior to the large presentation. Choose an effective visual. Choose an effective visual. Specific visuals are designed for specific type of data sets. For instance, scatter plot display the relationship between two variables well, while line graphs display time series data well. Ensure that the visual actually assists the audience in understanding your main takeaway. Misalignment of charts and data can result in the opposite, confusing your audience further versus the providing clarity. Keep it very simple. Data visualization tool can make it easy to add all sorts of information to your visuals. However, just because you can, it does not mean that you should. In data visualization, you want to be very deliberate about the additional information that you add to focus user attention. Elements of good visualization: clear heading and keys, obvious trend, simple analysis, relevant comparison, lots of data evidence, and summary of the key points. Clear heading and keys. One of the easiest, clearest way to communicate a message with the data visualization is through the heading and keys. Proper labeling of the data. The more compelling the heading, the more attention the reader will pay to the data in the chart or graph. To create the most compelling heading possible, you have to understand your audience. For example, do not use technical terms or jargon to communicate to the general public. One of the main benefits of data visualization is its usefulness in the showing trends. It can take a lot of time and effort pouring through reports to spot a trend, but a chart or graph can make one obvious in an instant. So if you have a trend, point point it out, lay out all the data you have and use lines to connect the dots like this graph does. The reader can get specific information from the bar graph while immediately picking up on the trend that the line depicts. Simple analysis. Not all data visualization has to come in the form of chart or graphs. Sometimes just a simple, well-organized table will do the trick. In fact, clearly breaking down valuable analysis like this saves the reader work because they do not have to interpret the data themselves. You can do the math for them to make the takeaway as obvious and basically inarguable as possible. Keep the information simple and brief and use bold and or colored font or key points. You can even add a short summary sentence or two to emphasize the overall message. Relevant comparison. Comparison can be very effective data visualization tool. Whether you are trying to drive home a point or encourage a particular behavior in readers, comparison help put your data into context. This works best when you have to got various sets of data that are directly comparable. Relevant comparison. Displaying the current data alongside averages and standards, for example, shows the reader not only how things are but how they could or should be. And more detail you can provide with the comparison, the better. Lots of data and evidence. The more points, essentially evidence, you represent in the data visualization, the more compelling the overall picture can become. Trends look more established and outliers look more exceptional. That said, take care to the present data clearly. Summary of the key points. In certain situations, data visualization in traditional sense with the colored graphics is not the most effective way to display information. You need something shorter and clearer than a detailed report, but chart and graphs would be overkill. Comparison to averages. If it seems like lots of data visualization uses the same common form and structure, bar graphs, pie chart, line graph and the like, there is a good reason. These kind of formats are both efficient and widely understood. And when the point is to communicate the quickly and clearly in a way that any reader can pick up on, it helps to make familiarity work in your favor. Now look at some examples. If you look at this particular graph, it shows some eggs and it are of different size. Scientists have recently figured out why different kind of birds have different egg shapes with data from almost 50,000 bird eggs collected over the last 100 years. The scientists looked at a number of variables including diet, adult body mass, nest type, nest location, number of eggs, nest and number of flying habits. The study showed that the length of an egg is related to the size of the bird's body, whereas the shape of the egg, the asymmetrical and elliptical shape relates to the bird flying habits. And this thing is represented in the form of a graph. And if you look at this particular image, this graph, it shows the government budget allocation to different sectors. So when it comes to the government budget, every country is guilty of making it extremely difficult for the general public to understand. This tree map was designed at the White House during the Obama's presidency to visually break down the United States 2016 budget, and it shows clearly that which area is having the maximum share of the budget, so that the audience will able to easily understood that how budget allocation is done. It certainly isn't the most innovative tree map or nor an interactive one. It is the fairly basic data visualization example at the best. However, this tree map broke news due to the fact that the major world power adopted data visualization technique to communicate to its people about where the tax money would go. Selfie city. If you look at this picture, it shows the different images of a different people with different selfie styles. So in an interesting turn of events where no one would ever predicted selfies to become useful data, Selfie City does a brilliant job with them. A total of 120,000 selfies were analyzed to study how people from around the world take selfies. What is incredible about this study is how seriously it takes each and every bit of a selfie. You can find trends in almost every from smile frequency to head tilt to pose trend to gender and more. For example, Sao Paulo women tend to take selfies with an extreme head tilt as compared to rest of the world. In Bangkok, the selfie is all about the smiles. The Napoleon March tells the story of the Napoleon March to Moscow in 1812 to conquer the city of Italy, which was a disaster. He started the march with around 4,70,000 soldiers and only returned 10,000 soldiers. This chart has become one of the most famous data visualization examples of all time. The width of the line shows the total number of soldiers. The color represents the direction of journey. Yellow for marching toward the Moscow and black for the return trip. It also contains simple temperature line graph to illustrate the dropping temperature at the time. Now it is time to jump to the practical demonstration of same. As we are discussing about advanced data visualization, now for this we need to use a software with which we can convert the data into the graphs and very interesting data visualization. The software that we have to use is Tableau. And this is the interface of the Tableau software. If you look at when you open the software Tableau, so if you see here, there are different files that we can use it for the purpose of analysis. You can use Microsoft Excel file, text file, JSON file, Microsoft Access, PDF file, and different servers can be connected for the live data access. Although if you want to learn this, then there are some inbuilt data sets like sample superstore and word indicators. Once you click on sample superstore dataset, you will be directed to this particular interface which will give you the information about different sheets. This dataset contains one order sheet, people, return, and the joins are created, and then when you click here on the sheet, so you will get this interface. So I'll explain you about this interface. Now in this interface, you see here there are different menus, and these are the charts available with which we can play with the data visualization. These are the filters. Now, when we have to work with the Tableau, these are the most important things. You see here, this is called as the dimensions, and these are the measures. So, dimensions are basically the non-numeric data, and measures are the numeric data. And if you look at here, if you look at this location, country, origin, and when you click here on the country origin, you see this is a string variable. So string variable, it shows it is string variable. And if you click at here on the discount, so it shows it is a number decimal. So again, if you click at order ID here, ABC, it is string variable. So if you click here, there is one data type. If you see profit and location, order date. So order date, it is a date variable. So the type, it is very important to understand the type of a data. Type of a data, it consists of basically majorly two types of a data. One is numeric and one is non-numeric. So non-numeric data is basically dimensions. You see here, it is a dimension. When we import a data, the data set contains different attributes. Attribute means the column names. The column names, those are basically the string variables or the date variable. That variable will get placed here in the dimensions when data is imported in the Tableau. When basically the quantitative data is placed in the measures like discount, profit, quantity, and sales. Now when you import, let's suppose we imported this data here in the row, and the data, the profit, we imported here. So this data is imported, okay, this country, and this is the profit which is imported here. So we can interchange this also. So whatever type of the graph, like if you want state-wise data, so it can give you the state-wise data also. You can remove this. So this is the state-wise data which can be created like this. And if you click here, the state, it shows all the variables, and if you click here, so it shows, so it is discrete or it is a continuous data, so it can be shown like this, basically. So this is how the data is represented. This is the inbuilt data set, the sample superstore, so which can be used to learn how it works. So before we moving further to create more interactive charts, so just I have explained you that while working with the Tableau, there are two things. One is dimension and one are the measure. Now going back to the measure interface, so here if we want to import any text file, so if we want to import any text file, then we need to click on a text file, and on desktop, so there are different files and the allowed formats are, you see here, there are different formats that are allowed. So here this electronic card transaction July 2022, I click here on this and click on the open. Now this, when I move to the sheet, so this particular electronic card transaction data is opened in the Tableau. So now we will close this data set superstore. It is open twice. Okay. Now this is the electronic card transaction data. Now these are the, okay, here these are the dimensions and these are the measures. Now if we look at the data set, this electronic card transaction data set here, so the attributes period, data value and magnitude, these three attributes are numeric, and in the Tableau, so these data value, magnitude and period, they are in the measures. Rest all are in the dimensions. So now this practical help you to understand that what are the dimensions and what are the measures. It is very important to understand, so what are the dimensions and what are the measures, basically. So dimensions are the non-numeric and measures are the numeric values. And if you want to see in detail, you see here, when you click here on the data value, so it shows the number. When you click here on ABC, it shows it is a string variable. Fine. So again, moving back to the measure interface, when you click on text file, so even if you click on the PDF file, so you can open PDF file and click OK. So if the PDF file is big, it will take some time to scan. Now if you see here in the sheet 2, so whatever tables are there in the PDF file, it will scan and convert the tables and ready to use it for the purpose of analysis. So you see here all these tables are converted here. So all these tables, okay, are there which can be used for the purpose of analysis. So the point is to explain that data from text file, Microsoft Excel, PDF can be imported in the Tableau. Now if you want to use a live server data, you can fetch the data live from any working server, working database. When you click here on the more, already there are 4 options: MySQL, Oracle, Amazon Redshift, Google Drive. When you click on the more, you will find almost all online databases like SAP, Sybase, Spark, Teradata, Presto, Salesforce, Dropbox, PowerPoint, Power Pivot, MongoDB, Spark SQL. So the live databases, okay, those who are used for storing data, Tableau can fetch data from these databases live. For example, this Google Drive. When you click on Google Drive, so when you click on the Google Drive database, if you want to fetch the Google Drive database, then it can fetch direct data from the Google Drive database also. So there is basically, when you want to process the data, there is some authentication request is there. So when you click on the Google Drive, it will authenticate, okay, the email, and ultimately it will able to fetch the data for which we can use it for the purpose of analysis. So I click on the Google Drive. This is the authentication page. I authenticated and allow the Tableau to use my email. So Tableau created this window to authenticate. It is now safe to close it. So now, okay, this window is closed, and again the software. So it is connected to my, okay, Google Drive, and different files are available in the Google Drive. So again, the same file which we have opened in the CSV is available in the Google Drive also. So I can open it from here also. So now you see directly it can fetch data from the live servers. So this is electronic card transaction data which is fetched from CSV. This is which is fetched from the Google Drive live. So no need to download data, directly we can fetch and use it for the purpose of analysis. This is how the Tableau work. So in theory, we discussed about the big data and data visualization. When data is very complex, when data is basically consists of large number of rows, high volume and high velocity. So that live data can be fetched and analysis can be done on the live data from this particular software Tableau. And when data is of different types, even if it is of text file, JSON file, Microsoft Access, PDF, and or different format or different servers, data can be fetched. For learning, we can refer to the sample superstore dataset which is already available, which help us to understand that how can we work with the different areas of the Tableau to learn filters, to learn graph, and to create different advanced charts which can be used for the purpose of decision making for the organization. So these are the dimension and these are the measures. So dimensions basically are non-numeric data, string variables or date variables, and measures are the numeric data values with which we can create the data visualization. Thanks. That's all for now.